Hi, my name is Nick Van Meter. This is my Construction Management 110 project, number 2. So I chose topic number 30, and that is to describe the steps involved in creating a cast-in-place concrete column. Alright, so the first step in the column construction will be the column layout. So first of all, the location of the columns has to be decided, and this will be presented in the drawings as can be seen above. And in the field, the columns are laid out by laying down rope in the same grid pattern as seen in the drawings and then marking that location. Once the correct layout of the cast-in-place concrete columns is determined, the next step is to fabricate the reinforcement for the concrete column. The material used for this is rebarb, and the rebarb is combined and attached to other rebarb with wire, and there will be different bar numbers of rebarb used, and that will all be specified from project to project. Here's some more information on column reinforcing. So, the vertical reinforcing bars increase the column's load carrying capacity and give it resistance to bending forces generated by lateral forces on the building structure or by connected beams. The ties are lighter in weight and wrap around the vertical bars to resist outward buckling of the bars, and the ties also increase a column's resistance to extreme cyclical seismic loads, or also known as earthquakes. Once the reinforcements have been constructed, the next step is to place the formwork for the cast-in-place concrete column. For placing the formwork is usually made out of wood and metal, a combination of the both. Once the formwork is placed, it is connected through ties and supported with snap ties and braces. So all those are to support the formwork and prevent it from moving while it holds the concrete, which will be poured in the following step. The actual pouring of the concrete into the column's formwork can be done manually as seen here, or mechanically as seen here. Mechanically is preferred for larger projects where a larger quantity of concrete is needed. For a small quantity of concrete, a machine mix concrete would be okay, but for a larger quantity, a ready mix concrete was preferable. If the column is over 1.5 meters high, a machine is recommended to be used to fill the column because the concrete cannot fall from a height greater than 1.5 meters. It has a height range of 1.5 meters because if it is dropped from a higher height than that, segregation can occur. After the concrete has been poured and it is cured and hardened and the formwork is removed, it does still need a cure. So the standard concrete will need a cure for 7 days in ambient temperatures, usually above 40 degrees Fahrenheit. And as can be seen here, wet blankets or tarps have been draped around the concrete to aid in the curing process. It helps keep the concrete moist and serves as a type of insulation. As can be seen here are some finished examples of cast-in-place concrete columns. There are obviously many different types of molds or different types of formwork you can do to create different types of shapes or styles of concrete columns, leading to basically an endless world of possibilities or customization. Alright, to kind of wrap up the video, I'm just going to do a few reminders on the construction process of a cast-in-place concrete column. So first of all, if a smaller amount of concrete is needed, machine mix concrete is the way to go, and if a larger amount of concrete is needed, ready mix concrete is the way to go. Another reminder is to only pour concrete from a height below 1.5 meters. If the concrete is poured above a height of 1.5 meters to the bottom where it's going to land, it would lead to segregation. And lastly, a last reminder is to check to see if the column is vertical and if it is horizontally correct too, so the grid aligns up. Alright, so thanks for watching the video. I hope you guys have a good one.